And what we're going to be covering this week is law of sines and law of cosines. Now, law of sines and law of cosines deals with triangles that are not right triangles. Because our formulas, bless you, sine of theta is equal to opposite over the hypotenuse, and cosine of theta is equal to the adjacent over the hypotenuse, and tangent of theta is equal to opposite over the adjacent. These setups only work if it is a right triangle, because these here only work if it is a right triangle. One of the angles has to be 90 degrees. But there's lots and lots of triangles that are not going to be a right triangle, because we can deal with other angles than having one restricted at 90 degrees. So one of the theorems that we have is law of cosines. Now there's two main ways that this law is set up, or this formula is set up. One of them is sine of A over A is equal to sine of B over B is equal to sine of C over C. Now with angles and sides, the angles are always going to be opposite the corresponding side lengths. So angle A and side length A. Angle B, side length B, and angle C and side length C. They're always opposite. Angle C is opposite side length C. Angle A is opposite side length A. And angle B is opposite side length B. And they always match these up. Side lengths are always going to be lowercase. Angles are always going to be capital. And we can use these to solve for the missing side length of any side of a triangle. Now, law of sines has some particularities to it, and we won't get fully in depth into what they are. But we're going to look at two main cases. And the one that we're going to be dealing with today is this one here. A over sine of A is equal to B over sine of B is equal to C over sine of C. Now, we're not going to use all three. We're only going to use two, because in an equation, we only really have two sides. We're only going to use two of these. A over sine of A is equal to B over sine of B, or whichever one. But we're only going to have two of them to solve, because they're all equal. And so let's look at this first problem here, and using this formula. Because once we start using it and seeing how this works, it's actually not as complicated as you might think. Now we're given this triangle here, ABC. We're told that angle C is 107 and angle B is 25. And we're given a side length of 15. Side length B is 15. And what we want to do is we want to solve for all the missing sides and angles. And we're going to round to the nearest tenth. So can we find the missing angle? What do we know about triangles and angles? They all add up to be 180. So if I know two of the angles, I can find the third, because all three add together to be 180. So what we could do is I could take 107 and add to it 25. We can add these two together. 2, which would be 132. And we can subtract 132 from 180, which will give us I believe it should be 48. 48. So we did that there to find the missing angle, because it's going to be helpful to find all three, and finding the missing angle when we're given two angles is a little bit easier than finding the missing side lengths first. Okay. Any questions on anything we've done so far? Well, we really haven't done anything new yet, because we knew how to do that before. Okay. What we're going to do next is solve for a missing side. Now, when we solve for missing sides, we need to have that side, so one of the missing sides, and the angle opposite it. So say we're looking at side length A. So A is going to go on top. Because when we look at the formula, A over sine of A is equal to B over sine of B is equal to C over sine of C. That is our formula. So we're going to have A over sine of what? 48, because 48 is the angle opposite A. Because it's the side over sine of that angle opposite that side. Now, we need the other half. So we're good. Is everybody good with this first part? Yes? Now, how many things can I solve for in an equation? I can only solve for one thing at a time, right? Because even in Algebra 1, when we solved for x and y, we did systems. Well, I had to solve for one variable first, and then I could solve for the other. I can only do one thing at a time. So that means whatever goes on this side of the fraction needs to be numbers. So are we given a length already? Which is? Okay, so I'm going to use it. Over sine of. So the other side of this equation is 15 over sine of 25. Because 15 is a number, sine of 25 is, well, a number, because we did that last chapter. We can type in sine of 25 and we would get a value. But we're not going to do that quite yet. So any questions on anything we've done thus far? Okay, we need to get A by itself, yes? Well, what is with A? Right, we have sine of 48 on bottom, yes? What multiply what? Multiply both sides by what? Sine of 48. We're going to multiply both sides by sine of 48. Because when we do this here, so on the one side here, when we multiply this, we'd have sine of 48 over sine of 48. Well, anything divided by itself is 1. So really that cancels out. We don't have to technically write that in. But that side would cancel out. Now over here we would have 15 times sine of over sine of. Okay. Which really tells me A is equal to 15 sine of 48 over sine of 25. Now, looking at that there, so A is our variable we're wanting to solve for. We know 15 is a number. Sine of 48 and sine of 25, can I turn those into just numbers? Can the calculator turn that into a decimal? So is everything on this side 15 times sine of 48 over sine of 25? That's all just a number, yes? Type it in. Go on and just type it in exactly as we have it. Type that straight into the calculator and see what you get. What was it? 26.4, 26.37. Yep, 26.4 since we're going to one decimal place. Going to the tens. And that's it. That's all we have to do to find the side length A. 26.4. Any questions on this here before we move on to side length C? Okay. Erase all this here. So we're going to do this again because we want to find both missing sides and the missing angle. Well, we found one side and one angle. We still need to find the other side. Side length C. Well, sine of 107 because 107 is the angle opposite side length C. So that's how we have this set up is side length C over sine of the angle opposite, which would be sine of 107, is equal to what? I'm just going to use this. I'm going to use this setup because it's going to be more accurate. Because this here, the side length given, 15, well, that's exactly 15, isn't it? What did we do with the 26.4? We rounded, didn't we? So this other side length, the side length A, is it exactly 26.4? No, it's a non-repeating, non-terminating decimal. It went off forever. So when I work these, personally, when I work these, I try to stick to whole numbers if I can stay to that way. Since I know 15 is a whole number over sine of 25, it works out, yes? So what would we do? Well, we do the same thing we did last time, yes? We're going to multiply both sides by sine of 107. And these here would cancel, giving us C is equal to over so some of y'all have that typed into the calculator, or we typed it in similar to it already in the calculator, yes? In the calculator, if you hit the up arrow, have you seen how it goes and highlights above? Have y'all seen that or worked with that? Go on and highlight what we had before, the one that you typed in first. Hit enter once you get it highlighted. Yep, it'll bring it down. And what we can do is we can change 48 to 107, yes? Well, that made it a little bit easier to type in, didn't it? Because I type it in once, I go up, bring it down, and we can edit. And that's it. That's all we have to do for this here. Now, one way that we can know that we got the right ones, 33.9. What is the biggest angle in this triangle? The biggest side is always opposite the biggest angle. 33.9 is the biggest side. It is opposite the biggest angle, so we know we got this right. That's it. That's all we have to do with this here. Questions on this here? Let's look at another one. For this to work, we always need a side. We need to know a side and the angle opposite, and another angle or another side. So do we have a side and an angle opposite it? We have 25 and 38, so this will work. Do we want to start finding side first or angles first? Angles a little bit easier, yes, because all three angles add up to be 180. So we can add 38 and 115. Three. Right, we would add them together to get 153. And if we subtracted from 180, we would get 27. Or we can just subtract both of them from 180 and get 27. So luckily, finding the missing angle is not that bad. So Caleb, what do we want to find first? B or C? B. Okay, so we would have B over sine of what? 27 is equal to what over what? 25 over 38, yes. 25 over sine of 38. What do we do next? We multiply both sides by sine of 27. Because we're trying to get the variable by itself. And when I multiply both sides by sine of 27, well, the sine of 27 would simplify, leaving us with b is equal to 25 times sine of 27 over sine of 38. We all agree with 18.4? Yes? And that makes sense. Because the side length that was given was 25, and its angle was 38. 27 is a little bit smaller than 28. So we should expect a side length that's a little bit smaller than 25. So 18.4 is our side length. So any questions on how we found side length B? You ready to find side length C? 18.4? 18.24 would be a little weird. Okay. Well, we can really keep 25 over sine of 38. That still works out for our problem. Now we're missing side length C, and this is going to be over sine of, what would that be? (115), because 115 is opposite side length C. So we want side length C in the angle opposite it. And this time we would multiply both sides by sine of 115. And we do this here, well, sine of 115 and sine of 115 would cancel out, leaving us with C is equal to 25 times sine of 115 over and this here is what? 36.8. Any questions on any of this here? Are we good with this here? Yes? Any questions on any of this here? I do know that we have two more of these here, but I feel like how this is going, y'all are good with this here. We don't need to see another example because this is going to be the exact same as what we just did, yes? Okay. Now, yeah, and it would still work out the same. Because we could call this B and C. So here we would do B over sine of 70 is equal to, we would just need to find that angle. 9 would make 90, and then we would just need 29. So it would work out. We would just need to find that angle. Now, I said earlier that this here, law of sines, works well for some of them, yes? that there's not, well, it doesn't, not that it works well for some of them, that there's a hiccup to it, yes? Because I said that at the beginning there's a hiccup. Now, the reason that there is a slight hiccup with this is, well, heck, if I can, if we call this 2 and we say that this is, say, 24 degrees. Let's do, heck, what's the best way to do this? There we go. Now, y'all know that this here, this compass is good for drawing circles, yes? Okay, that's not what I wanted. There we go. So what we can have is this here. Make it a little bit bigger. There we go. We can have triangles like this here. Because what's worked out and what this is doing and what this is showing is that this length here, from here to here, is the same going to be the same. I'll get this to draw. All right. As from here to here. So if we said that this was 4, these are just measures, but those lines would be the same, yes? Now what we have is a triangle, these two triangles, this one here, and this one here, both have side lengths of 2 and 4, and an angle that is 24 degrees, yes? Yes. But are they the same? Well, no. This is where the hiccup comes. This is law of sines. Because what we can deal with is a spot where there are 2 cases. Because given 2 sides and an angle, there is a chance with law of sines that we could have a case where there's 2 triangles that hold true. Remember, this is side, side, angle. Was that one of our congruency shortcuts? No, that's one of the ones that didn't work. So that's where one of the hiccups comes. But we're not going to deal too much in that case. We're mainly going to look at the ones that only have one case.